हेलो 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 डियर स्टूडेंट्स, अभी हमने पढ़ा था एक्यूट एंगल ट्रायंगल थ्योरम और स्टेवर्ट थ्योरम के बारे में। अभी मैं आपको पढ़ा रहा हूँ मिडपॉइंट थ्योरम, फिर हम काफ़ी सारे रिजल्ट्स उसके ऊपर धीरे धीरे डेराइव करना शुरू कर देंगे। सो मिडपॉइंट थ्योरम क्या होती है बेटा हमारे पास? मिडपॉइंट थ्योरम it states that in a triangle the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and is half of it. It states that in any triangle ABC the line segment joining the midpoint of the sides the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and is half of it. यानी कि मैं कहना चाहूंगा आपको यहाँ पर क्या है गिवन हमारे पास given is D and E are the midpoints of AB and AC respectively. Then we have to prove that DE is parallel to BC and DE is half of BC. किसी भी ट्रायंगल के अंदर the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. तो देखते हैं कैसे करेंगे हम इसको। सिंपल सिंपल से रिजल्ट से हमने कंस्ट्रक्शन करी कि प्रोड्यूस DE to F such that DE is equal to EF। हमने DE को F तक प्रोड्यूस कर दिया कि DE और EF हमारे बराबर आ जाए एंड ज्वाइन CF और हमने CF को ज्वाइन कर दिया। ठीक है बेटे, ध्यान से देखिएगा होगा क्या हमारे पास E जो है वो हमारा मिडपॉइंट दिया हुआ है यानी कि दिस साइड इज इक्वल टू दिस साइड। ये वाली साइड इस वाली साइड के बराबर है, ये वाली साइड इस वाली साइड के बराबर कंस्ट्रक्ट करी। एंगल 1 इज इक्वल टू एंगल 2। सो बाय SCF कॉन्ग्रुएंस ट्रायंगल AED इज कॉन्ग्रुएंट टू ट्रायंगल CEF। हमने इसको प्रोड्यूस किया था सो दैट DE जो है वो EF के बराबर आ जाए, एंगल 1 एंगल 2 के बराबर आ जाए, दिस साइड इज इक्वल टू दिस साइड। सो बाय SAS कॉन्ग्रुएंस ट्रायंगल्स आर कॉन्ग्रुएंट। ट्रायंगल्स अगर कॉन्ग्रुएंट अगर होंगे हमारे पास तो इसका मतलब क्या है? ट्रायंगल कॉन्ग्रुएंट होने का फायदा क्या मिलेगा? एक तो हमारे पास जो ये वाला एंगल है वो इस वाले एंगल के बराबर आ जाएगा यानी कि एंगल EAD। अगर मैं इसकी नंबरिंग करता हूँ 1 2 3 1 2 3 के हिसाब से, ठीक है, एंगल EAD इज इक्वल टू एंगल ECF। EAD वाला एंगल है वो ECF के बराबर आ जाएगा यानी कि एंगल C जो है एंगल 4 के बराबर आ जाएगा। जो एंगल C एंगल 4 के बराबर आए तो इसका मतलब AD इज पैरेलल टू CF। ये वाली लाइन जो है वो उसके पैरेलल हो जाएगी। साथ साथ मैं कहना चाहूंगा कि AD जो है हमारे पास वो CF के बराबर आ जाएगा बेटे। ये वाली जो लाइन है वो इस वाली लाइन के बराबर आ जाएगी बट AD इज गिवन टू बी इक्वल टू BD। ठीक है, AD is given to be BD and AD is parallel to CF. It means BD is parallel to CF in this, okay, and you can write this as well, that is BD is equal to CF। BD जो है वो CF के बराबर आ गई and BD is parallel to CF। BD is equal to CF and BD is parallel to CF। So in a quadrilateral, if one pair of both sides is equal and parallel, then it is a parallelogram। So here BDFC is a parallelogram। Okay, here BDFC is a parallelogram। If it is a parallelogram, what we are having is BC is equal to DF। BC is equal to DF, and DF is DE plus EF. Both the sides are equal, so it becomes twice of DE. So DE comes out to be half of BC, as well as since BC is parallel to DF, it means BC is parallel to DE। Okay, so in any triangle ABC, if D and E are the midpoints of the sides AB and AC, then DE is parallel to BC and DE is half of BC। So converts भी true हो जाता है बेटा। Converts का मतलब क्या है? If D is a midpoint of AB and this line is parallel to this, then it bisects the third side AC। ठीक है, अगर मैं इसका कन्वर्स अगर प्रूव करना चाहूँ तो इसका कन्वर्स यहाँ बता सकता हूँ. If we have to prove the converse part, it has been given that D is the midpoint of this and D is parallel to BC, and we have to prove that E is the midpoint of AC. There are again two ways we can do the proof. You can prove like this. Just draw a line parallel to, just draw a line CF which is parallel to BD, which cuts DE produce arrow point F. आपने क्या किया, एक लाइन ड्रॉ करी इसके पैरेलल जो D को F पे कट कर रही है. ठीक है बेटे, जब पैरेलल अगर आएगी तो इसका मतलब क्या है, एंगल 1 इज इक्वल टू एंगल 2. हमारे पास क्या दे रखा है, इट इज गिवन दैट दिस इज अ मिडपॉइंट, दिस लाइन इज पैरेलल टू दिस लाइन. ओके, हमने कंस्ट्रक्ट क्या करी, हमने ये वाली लाइन इसके पैरेलल ड्रॉ कर दी. जब ये वाली लाइन इसके पैरेलल ड्रॉ करी, ये इसके पैरेलल है, तो इसका मतलब डी डी एफ सी तो पैरेललोग्राम हो जाएगा ना हमारे पास बेटे. बी डी एफ सी जब पैरेललोग्राम हो जाएगा हमारे पास, तो इसका मतलब सी एफ जो है वो बी डी के बराबर आ जाएगा. बी डी तो ए डी के बराबर है हमारे पास. ठीक है बेटे, तो इसका मतलब है सी एफ इज इक्वल टू बी डी. लाइन्स पैरेलल से एंगल 1 एंगल 2 के बराबर आ गया. दिस एंगल इज इक्वल टू दिस एंगल 3 is equal to angle 4. So by AAS congruences, this triangle is congruent to this triangle. It means in that case AAS congruences triangle, this point is E, triangle EAD becomes the congruent to triangle ECF by AAS congruences. Therefore what we are having is AE comes out to be equal to CE. This side comes out to be equal to this side. It is converse of midpoint theorem is also true. That is, in any triangle, if D is a midpoint of AB, you can say, and DE is parallel to BC, then it bisects the third side. That is, a line is drawn from the midpoint of one side of a triangle parallel to the third side, then it bisects the another side. Okay. Now, if we have to prove that in a triangle all the medians are concurrent and the centroid divides the median in the ratio 2:1, the first one which I taught you in my first lecture when I was giving you the basic overview of the geometry. Okay. Now we have to prove that in a triangle all the medians are concurrent. All the medians are concurrent and their point of intersection that is centroid divide the median in the ratio 2:1. ठीक है बेटे, हमारे पास क्या दिया हुआ है, क्वेश्चन कहता है if ABC is a triangle, in any triangle ABC, it has been given that you can say as BE and CF are the median. BE and CF given is in triangle ABC. BE and CF are the medians. Okay. Let they intersect at G. Okay. We have to prove that all the medians are concurrent. That is, we have to prove that, and you can say as we have to prove that all the medians are concurrent, and let's say you can say as if I produce AG, join AG and produce it to cut join AG and produce it to cut BC at D. आपने AG को ज्वाइन कर दिया, ठीक है बेटे, which cuts BC at a point D. So we will prove that AD is a median. That is, we have to prove that BD is equal to DC. It has been given that BE and CF are the medians. Let them intersect at a point G. Now, if I join AG and produce it to cut the point BC at a point D. Now if I can prove that BD is equal to DC, then it means AD is a median. Second result, we will prove that AG is to GD, the ratio is 2:1. Okay, AG upon GD and another ratio BG is to GF, D and CG is to GF is 2:1. So what we will do is, we are doing the construction work here. Produce AD to K such that, this is one of the important construction, produce AD to K such that AG is equal to GK. Just keep this in mind. We have to produce AD to K such that AG becomes equal to GK. Okay, and join BK and CK. We just join BK and CK. Okay, so now you can see here as in triangle ABK. In triangle ABK, I am just writing here. In triangle ABK, you can see in this triangle A, B and K, F is a midpoint of AB, because it is being given that CF is a median, BE is also median. That is, F is a midpoint of AB and E is a midpoint of AC. So in triangle ABK, F is a midpoint of AB and G is also the midpoint of BK. That is, in triangle ABK, F and G are the midpoints of, they are the midpoints of AB and AK respectively. Therefore, by midpoint theorem, what we are having is FG is parallel to BK and FG is half of BK. मिडपॉइंट थ्योरम से हमारे पास क्या आ जाएगा बेटे, FG जो है वो BK के पैरेलल आ जाएगी और FG इसके हाफ भी आ जाएगी हमारे पास. That is, this side is parallel to this side. That is, GC is parallel to BK. FG is parallel to BK means GC is parallel to BK. Okay. Similarly, in triangle AKC. What we are having is G is the midpoint of AK and E is the midpoint of AC. मैंने कहा G जो है वो AK का midpoint है, E जो है वो AC का midpoint है. So midpoint थ्योरम से GE जो है वो KC के पैरेलल आ जाएगी. ठीक है बेटे? G and E are the midpoints of AK and AC respectively. Therefore, GE is parallel to KC. GE is parallel to KC, as well as you can say as GE is half of KC. So GE means BG is parallel to KC. Okay, that is this line is parallel to this line. Okay, so you can see here as this is parallel to this and this is parallel to this. As you can see as GC is parallel to BK, that is BG is parallel to KC. BG is parallel to KC and BK is parallel to GC. From these two, what we are getting is BGCK is a parallelogram. As in a quadrilateral, if both the pair of both sides are parallel to each other, then it is a parallelogram. That is, this is parallel to this and this is parallel to this. It means BGCK is a parallelogram. Okay. So if it is a parallelogram, and we know that in a parallelogram diagonals bisect each other. So what we get is BD is equal to DC. That is, in a parallelogram, diagonals bisect each other. So what we get is bisect each other. Therefore, BD is equal to DC. That is, AD is a median. Okay. As well as you can say as GD is equal to BK. That be equal to small x. GD comes out to be equal to AK. This is small x, then this is small x. That is, GK comes out to be twice of x. Therefore, AG is equal to GK comes out to be twice of x. AG is equal to GK twice of x. So therefore, AG is to GD. That is twice of x upon x comes out to be 2:1. That is, AG upon GD comes out to be in the ratio 2:1. Okay. You can also see here as GE was half of KC. From where you can see here as GE was half of KC. This is it. GE is half of KC, and KC is equal to BG because it is a parallelogram. KC is equal to BG. You can say here as GE is half of BG. That is BG upon GE also comes out to be equal to 2:1. Okay. Here we have seen that GE is half of KC. KC is equal to BG. That is GE is half of BG. That is BG is to GE is 2:1. Similarly, you have seen, you have derived here that FG is half of BK. FG is half of BK, and BK is equal to GC. Okay, this is half of GC. So you can get here as GC is to FG, yeah, GF is again 2:1. That is GC is to GF is comes out to be 2:1. Easy. That is center divided the median in the ratio of 2:1. Hope it is clear to all of you. I will derive all the results which I have shown you in my first lecture. Okay. Now I will derive some properties of a Pythagoras theorem as well, and some properties on the right angle triangle. Okay, let us see. If ABC is a right angle triangle, right angle at A. So if I draw perpendicular on AD on PC, I am just deriving the very important results of a right angle triangle. If ABC is a right angle triangle, right angle at A and AD is perpendicular to BC, then there is one theorem which states that if a perpendicular is drawn from the vertex of a right angle triangle, then triangle on both sides of the perpendicular are similar to each other and similar to the whole triangle. I hope you know the concept of similarity as well. In case of congruency, they are overlapping figures. In case of similarity, the angles are equal and sides in a constant ratio. Okay, the same ratio. Okay. So what I am saying is, किसी भी right angle triangle के अंदर अगर मैं perpendicular draw करता हूँ, then triangle on both sides of the perpendicular are similar to each other and similar to the whole triangle. So what I would like to say is, in triangle BDA and triangle BAC, नोटेशन आप देखिएगा, BDA इस वाले ट्रायंगल के अंदर और बड़े वाले ट्रायंगल के अंदर पहला जो लेटर मैंने लिखा हुआ लिया कॉमन, BDA वाला ट्रायंगल और BAC के अंदर पहला वाला लेटर मैंने कॉमन लिया हुआ है. सेकंड जो लेटर मैंने लिया हुआ वो है राइट एंगल वाला. BDA के अंदर राइट एंगल किस पे था और BAC के अंदर राइट एंगल किस पे था. बाकी जो थर्ड लेटर जो बचेगा, दैट इज इन ट्रायंगल BDA एंड ट्रायंगल BAC. So what I am writing is, you can see here as this is angle DBA is equal to ABC. This is common in both this triangle. I am considering this triangle as well as all triangle. So angle DBA is equal to angle BAC. Also angle BDA is equal to angle BAC. That is 90 degrees. Therefore, by AA similarity, in a triangle if two angles are equal, obviously the third angle must be equal. So triangles are similar. So by AA similarity, triangle BDA is similar to triangle BAC. BDA वाला जो ट्रायंगल है वो बेटा BAC वाले ट्रायंगल से सिमिलर हो जाएगा. तो सिमिलरिटी रेशियो से हम लोग क्या करेंगे, दैट इज वी कैन राइट दिस एज BD upon BA, 1:2 upon 1:2. Okay, this is 1:3, that is BA upon BC. Okay, BA, or I can write AB, that is AB square. You can write as AB square is equal to BD into BC. This is one of the important results in a right angle triangle. That is AB square. I am just writing the important results here. That is AB square is equal to BD into BC. These are the standard results which you can use in a right angle triangle when the perpendicular is given. So in triangle ABC, I had derived this result, that is AB square comes out to be BD into BC. Okay, this is one of the standard results. Second result is, if you are considering triangle CDA, in triangle CDA and triangle CBA, CAB. What I have taken is the letter common. This is the common angle. The 90 degree third vertex, common 90 degree third vertex, common 90 degree third vertex. Okay. So I am writing this as 1, 2, 3 and 1, 2, 3 here. So here angle DCA is equal to ACB. This angle DCA is equal to ACB. Reason is common. Okay. Then angle CDA is equal to CAB. That is 90 degrees. Therefore, by AA similarity, what we are having is triangle CDA is similar to CAB. CDA is similar to CAB. So what we are having is CD upon CA, that is this upon this, is equal to CA upon CB, that is CA square, that is equal to AC square, is equal to CD into CB. Though there is a concept of directed line segment, we will discuss it later. So I am writing AC square is equal to CD into CB. Okay, this is another second result. AC square in a right angle triangle, ABC is a right angle triangle, if AD is a perpendicular, then AC square is equal to CD into CB. This CD into CB. These are the very important results. So if you are adding these two results, if I can add 1 plus 2, let us see what is happening here. That is AB square plus AC square becomes BD into BC plus CD into CB. CD or CB you can write BC as, let's say same CB or BC. This is, you can write BC common. This is BD plus CD. So BD plus CD, again it comes out to BC into BC. That is, it comes out to BC square. This is the important Pythagoras theorem. That is in a right angle triangle. The square of the hypotenuse, the square of the longest side, BC square is equal to AB square plus AC square. Okay, third result is AB square plus AC square is equal to BC square. We can get some more results like this way. Okay, is it clear? I am just writing one more important result. That is in triangle BDA and triangle ADC. How I am writing this angle ADC? You can see here as, let this be 1, this is 2, this is 3, this is 4. You can see here as angle 1 plus angle 2 is equal to 90 degrees. Angle 1 plus angle 2 is equal to 90 degrees. And angle 2 plus angle 3 also comes out to be 90 degrees. Angle 1 plus angle 2 is 90 degrees. Angle 2 plus angle 3 also comes out to be 90 degrees. It means angle 1 plus angle 2 is equal to angle 2 plus angle 3. We can just cancel out angle 2. So we can get angle 1 is equal to angle 3. Okay. This angle must be equal to this angle. If this is a right angle. Similarly, you can write as angle 2 plus angle 3 is equal to angle 3 plus angle 4. Both are equal to 90 degrees. So we can get angle 2 is equal to angle 4. That is, this angle must be equal to this angle. Okay. So in these two triangles, BDA and ADC, this angle is equal to this angle is equal to this angle. This is 90 degrees. You can say as triangle BDA is similar to triangle ADC. Okay. So we are getting one more important result. That is BD upon AD is equal to AD upon CD. That is AD square is equal to BD into CD. This is also one of the important results. That is in a right angle triangle ABC. In a right angle triangle ABC, AD square is equal to BD into DC. Okay. And one more important result I am deriving right now. Here I have added these two, 1 plus 2. But now what I am doing is I am just dividing these two, 1 by 2. Okay. So what we get is AB square upon AC square. That is, AB square is BD into BC. This is CD into CB. We can write BC. Cancel BC. That is, it comes out to BD upon CD. You can get this by area ratio theorem as well. There is one important theorem, area ratio theorem, that says the triangles are similar, then the ratio of their area is equal to ratio of square of their corresponding sides. Okay. So AB square upon AC square is equal to this upon this. This is one of the important results. That is AB square upon AC square is equal to BD square, BD upon CD. Okay, there's one more important result. I'm just writing here this way. That is AD square, you can write as AD square is equal to AB square minus BD square by using Pythagoras theorem. AD square is equal to this square minus this square. Also AD square comes out to be AC square minus CD square. That is AB square minus BD square, that is this square minus this square is equal to this square minus this square. Or you can write this as AB square plus CD square is equal to AC square plus BD square. That is in a right angle triangle, this square plus this square is equal to this square plus this square. Or this is one of the beautiful results, that is called a Carnot theorem. That is, you can say, if in any triangle, if AD is a perpendicular, I am talking about any triangle, that is if in any triangle if AD is a perpendicular, and if you can get, or you can say that in a triangle, in any triangle if AB square plus CD square is equal to AC square plus BD square. I am talking about in any triangle if AB square plus, in any triangle ABC, if D is any point such that this square plus this square is equal to this square plus this square, then this angle must be a right angle. You can prove it. This is a very beautiful result. You will use this result in a very good problems in Olympiad. That is, in a triangle, if D is any point, if you can prove that this square plus this square is equal to this square plus this square, then this is a right angle. Try to prove it. Okay. I'm telling you one more important result.